teach you will guide constant, never left the strangers.
Welcome to another virtual physics lecture. Today we're going to be discussing conservation of energy, specifically the different types of energy and their transformations. Be sure to take good notes and let's begin. Now that we are fully aware of work and power, let's talk about energy. What is it? Well, energy is basically the ability to do work. If an object or an organism does work, then it's basically exerting a force over a certain amount of distance to move that object. Therefore, the organism is using energy. Okay, so now let's discuss the units used for energy. Well, because there's such a direct connection between energy and work, energy is measured in joules as well. Lastly, but certainly not least, energy is extremely special and important because everything we do basically uses energy. Thus, energy is all around us. We're going to focus on this aspect in today's lecture. In fact, there's a law regarding energy, which is referred to as the law of conservation of energy, which is basically stating that energy can neither be created nor destroyed. It is essentially just transformed into other forms of energy. Because energy is never really destroyed, just transformed, that's why it's basically everything and needed by all. Living organisms, for one, need energy to grow and to move. For instance, we're using energy when hitting a softball or lifting your book bag or even when you're getting taller as you grow. So let's take a look at the different forms energy may take in order to do things. There's various forms of energy. However, we're going to be focusing on just these 6 forms of energy, starting with radiant, mechanical, chemical, electrical, nuclear, and thermal. I often remember these by thinking about a ram on a scent, the ram scent. Okay, now let's take a closer look at each of these forms, starting with radiant energy. Radiant energy is also known as electromagnetic radiation, coming from the sun, which is actually the biggest source of energy. And basically, any machines that work with X-rays, radio waves, visible light, etc., are dealing with electromagnetic radiation. Okay, so let's talk about light. Light is basically a form of electromagnetic energy. And each color of light that is seen in rainbows, remember Roy G. Biv? Well, they're basically representing a different amount of electromagnetic energy. Overall, radiant energy is basically energy from the sun or light bulbs, antennas, cell phones, etc. Next, let's look at mechanical energy. Mechanical energy can be energy due to an object's motion called kinetic energy, or it could be energy due to an object's position called potential energy, which are used to do work. But you also transfer energy when doing work, seen as momentum. In the next couple of lessons, we're going to be discussing these aspects of mechanical energy. So let's basically review what mechanical energy is. Well, mechanical energy is due to an object's motion, kinetic, or position, which is potential. For instance, when you kick a football, you give mechanical energy to the football to make it move. Let's look at this bowling ball. The bowling ball has mechanical energy. And when the ball strikes the pins, the mechanical energy is transferred to the pins. Okay, now let's look at chemical energy. Chemical energy is the energy that is stored in chemical bonds that are found in food, plants, batteries, etc. Well, whenever these bonds break, energy is actually released, such as burning coal or using a battery or eating cotton candy. These would all be examples of chemical energy. Okay, so what about electrical energy? Let's look at that one. Power lines carry electrical energy into your home in the form of electricity. This energy is the result of the movement of electrons, which are transported through power lines and converted into other forms of energy. So basically, whenever you're using electricity, you're actually using electrical energy. Okay, so now let's look at nuclear energy. I'm sure a lot of you have heard about nuclear power plants. However, they often get a really bad reputation because of all the potential dangers that can come from them whenever this power plant is not handled properly. However, if this nuclear power plant is handled properly, the amount of energy that can be released from it is just astonishing, especially the way that they do it. So basically, they're working with the nucleus of an atom. And there's two actions that they can take. Either they can split up a nucleus, and that's known as fission, or they can collide nuclei at high speeds and cause them to join, which is known as fusion. Either one of these two actions will cause a huge release in energy. Now, the problem is in being able to contain that energy, and that's where the potential dangers come from it, as well as the radioactive waste that comes from having this type of energy released. Lastly, let's look at thermal energy. Thermal energy is the internal motion of atoms, which is often called heat energy, because moving particles produce heat. Heat energy can be produced by friction. Heat energy can cause changes in temperature and the state of matter. Overall, heat energy is often the end product of many transformations of energy. Now that you know the different forms of energy, let's review really quick. Let's look at this microwave. What type of energy cooks food in the microwave? Well, if you said radiant energy, you're correct, because radiant energy uses microwaves, which fall under the category of electromagnetic energy. Okay, now here's another question. What about the spinning plate that is inside of the microwave? What would that be considered? Well, that would be considered mechanical energy because the object is in motion. Okay, so we've previously mentioned about conservation of energy, but what exactly does it say? Well, the law of conservation of energy basically just states that energy cannot be created nor destroyed. It can only be converted from one form of energy to another, which means that these changes that take place from one form of energy to another form of energy, they're often called as energy conversions or energy transformations. Okay, so what would be some examples of transformations of energy? Well, all forms of energy can be converted into other forms. Some examples would be the sun's energy through solar cells can be converted directly into electricity. Another one would be green plants converting the sun's energy into starches and sugars, which would be chemical energy. In an electric motor, electric energy is converted to mechanical energy. In a battery, chemical energy is converted into electromagnetic energy. The mechanical energy of a waterfall can also be converted into electric energy in a generator. Overall, energy transformations are seen everywhere. There's constant transformations of energy taking place. Okay, so let's look at some examples where we could try to figure out what forms of energy are being shown. So for instance, let's say that I light a match. What forms of energy would I actually be seeing here? Well, first off, let's start talking about the chemical bonds that are found inside of the matchstick. Well, these bonds are storing energy. And the moment that you light that match and that you start breaking apart those bonds, that energy is transformed into thermal energy because you're releasing all of that energy so that it can give off heat. Okay, what about a fan connected to an outlet? Well, when you plug a fan into an electrical outlet, electrical energy is transformed into mechanical energy, causing the fan blades to spin. All right, well, what about a lamp connected to an outlet? Well, when you plug a lamp to an electrical outlet, electrical energy is transformed into radiant energy, causing light to shine and giving us thermal energy, which is why the lamp gets hot after a while. Now, it's important to note that energy transformations are not always seen as a single line of conversions. In fact, it is often seen as multiple energy transformations, all working together all at once. So let's try out an example in which multiple energy transformations would be seen. Let's take a look at this automobile, for instance. This vehicle would have several energy transformations taking place at once the moment that the car starts to the moment that it is driving off. Okay, so let's try to list some of these out. Now, for instance, if we look at the battery of the car, the battery itself would be chemical energy. This energy can be transformed into many different forms of energy. But let's say that it got transformed into thermal energy. Well, that's why the chemical energy, which is inside of the battery, would be released as heat energy, causing that battery to start getting hot once it's running. Now, what about the electrical energy component? Okay, so the battery itself is giving electricity to all of the electrical components found inside of the car. And that in turn will end up giving you light inside of the car, causing you to go from chemical energy to electrical energy, and then lastly, electromagnetic energy. Okay, so there's another route that we could also take. From the chemical energy, which is in the battery, that would be transformed into the electrical energy, and then that would end up getting transformed into mechanical energy, which is what causes the car to actually move. Okay, so that's it for this video. Hope you guys took good notes, and I'll see you in class.
Ability to work heavy, constant, never left the